Thank you very much, everybody. Good morning. I'll talk about water quality testing in a rural setting in Uganda. Rural specifically because urban issues are often talked about. So my presentation will be as follows. The background is we still have access is low. Urban households don't have enough water. Access is also about 60%. We've had a lot of investment in infrastructure, but they've not yielded safe water. And even the national water quality has gone down. This meant more outbreaks of waterborne diseases, and rural quality was not receiving enough attention. And this affects the achievement of the Millennium Development Goals. So we did a study which was to assess the water quality and the causes of pollution, establish the preferred technology, and recommend feasible measures to deal with the problem of water pollution. We conducted it in Budaka. Our sample was 50 water sources, randomly selected, 30 boreholes, 15 springs, and 5 shallow wells. And we're testing microbiological parameters, chemical, and physical. So that is a map of Uganda. You can see we have a lot of districts. So we just selected one of the districts in the east, pointer in the green area, and it happens to be number 7 out of those. We have actually 114 districts in Uganda. Those are administrative units. So it's just one of the districts. We tested them using standard methods. That was fecal coliform, turbidity, even using a water test kit, pH meter, electroconductivity meter, TDS meter, spectrophotometer, as well as the analytical method, titration, and color comparator. We then determined the sanitation risk and computed the statistical mean, minimum, maximum values. We did linear and multiple regression so that we could relate the significances and correlations between the different variables. Then we also had correlation coefficients related to the T distribution and worked out a hypothesis. And finally, we did a water quality index based on 5 parameters, which were fecal coliform, turbidity, dissolved oxygen, nitrate, and pH. These were recommended by Ministry of Water as being significant for rural water monitoring. Now, these are results, the 3 types of technologies: boreholes, shallow wells, and springs. We compared both WHO guidelines and Uganda National Bureau of Standards guidelines, you can see. And then at the bottom there, you can see the water quality index for boreholes was higher than for shallow wells, and springs came second. We looked at percentage compliance as well to WHO and Uganda National Bureau of Standards. And you can see the different aspects show the different level of compliance. We continued with Uganda National Bureau of Standards because WHO standards are quite difficult to meet. Now this gives us our level of compliance. The biological was 97% for boreholes, physical was 83%, and chemical quality was about 99%. Meaning boreholes were the best source. So the results show high compliance for borehole quality, water quality, and suggest that where technology permits, we should promote deep borehole technologies in rural communities and elsewhere. Shallow wells, those are the least compliant, and therefore they should not be promoted unless we modify the design so as to reduce on the contamination. That's springs. So here's an example of a poorly maintained shallow well with a cracked apron, and that is a hand pump. And this is common in Uganda, many parts of Uganda. Protected springs were the second preferred, again because of their water quality compliance. They are less vulnerable to fecal coliform. The water quality index was determined to be about 59 and is classified as medium water quality according to Univ and C-squared standards. And it's the factors we observed that were determining the quality of water: maintenance of the source, presence of latrines nearby, and this showed a very important aspect with respect to maintenance of water. We noted that an improved water source does not guarantee compliance to WHO and UNI's water quality standards. But then the best technology is still the boreholes, and there's a strong linkage between the microbiological water quality and water source sanitation, as well as the closeness to latrines. Protected springs, if well maintained, can provide good water. Shallow wells are not recommended, but the long-term strategy would be small piped water supplies that will control the risk, and provided there is funding, will reduce the problem of rural water, poor water quality. Water sources should not be constructed downhill of pit latrines. Drinking water should be boiled, and there should be regular, effective operation and maintenance of these sources. Thank you very much.
Thank you very much.